Hi everybody, thanks for watching. In this video, we're going to cover the different types of symbols and notations used by chemists to describe an atom's identity, mass, and charge. Let's first start off by reviewing two really important terms you have to know in order to write the different symbols I'm going to show you in the video. Those are atomic number and mass. To explain them, I'm going to bring back the carbon atom from the first video. And we'll start off with atomic number because it's the easiest one. Atomic number is defined as the number of protons inside an atom. So just count the protons, that's the atomic number. The mass is a little more complicated. It's the protons plus the neutrons inside of an atom. And both of those definitions make up our first key idea for the video. Let's apply those two ideas to the atom you see on the left. Its atomic number, if it has 6 protons, is 6. And the mass, which is protons plus neutrons, 6 plus 6, gives us a mass of 12. Once you understand those two terms, we can start actually looking at some of the different symbols we're going to use to represent them. There's actually 3 different types of notations we're going to walk through, and this video is only going to cover the first one. It's the most common one and the most widely used, and we call it the isotopic notation. When you use isotopic notation, you follow the format shown on the left. This XZA is the typical way to represent it. I'll walk through each of those 3 variables and show you how to fill them in. The X is the first thing you would probably write down. It's simply the atomic symbol for whatever element you're talking about. If the element is carbon, you'd put a capital C. If it was lithium, you'd use an Li. Pretty much whatever the periodic table uses to represent that atom. The Z on the bottom left is where you put the atomic number, which remember is the amount of protons in the atom. And the A is in the top right, which is the atomic mass, the protons and the neutrons combined in that atom. The meaning of the X, Z, and A variables make up our third and final key idea for the video, so make sure you take some time to write those down. We're going to conclude the video by applying this format to some examples. We'll start off with a model of a fluorine atom, and we're going to practice writing the isotopic notation for the atom shown. The first thing you do is probably the X, which again is the symbol for the atom. I just know that the symbol for fluorine is a capital F. If you didn't know, you could look it up, you could Google it, or go to a periodic table and find out what symbol is used. Then I like to go to the bottom left first for the atomic number. I'm going to count the protons, all the little red positive symbols. That looks like there's 9 of them. Since there's 9 protons, the atomic number is also 9, and I put a 9 in the bottom left. In the top right, I'm going to put the atomic mass, which is those 9 protons, plus the neutrons. So the green dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 10 neutrons plus the 9 protons, the atomic mass is 19. Let's do one more example where instead we start with the isotopic notation and work in the other direction to find out how many protons, neutrons, and electrons are inside the atom. Easiest place to start is the fact that the atomic number is 17, meaning there's 17 protons. The neutrons take the most work because you have to use the mass of 35 to figure it out. If you know that protons plus neutrons give you a mass of 35, and if you already know there's 17 protons, what you're really saying is 17 plus what number is going to give me the mass of 35. And if you still can't do that in your head, you should be able to see that to solve this little equation, all you really do is subtract 17 from 35, giving you a neutron count of 18. The last subatomic particle to fill in are the electrons, which we haven't mentioned to this point, and we won't talk about them much in this video for now. We're just going to assume that this atom is neutral, which means it's not positive and it's not negative. So if we have 17 positive particles, we're also going to assume that there's going to be 17 negative particles to balance them out. And you can make that same assumption if you're given no other information about how many electrons are in the atom. And that actually concludes our coverage of isotopic notations. For information on the final 2 different types of atomic symbols, you'll have to watch the next video in the series.